Okay, so we are going to continue from where we left off the last time we met. Um, so basically, these are things we covered. We looked at strings into details. We looked at the methods and stuff like that. We also had looked at the arithmetic operations long before that. Then we looked at the comparison operators. Now, um, I don't know. Did we look at the conditional statements, if else, and the likes? Yes, please. Glenn, I can see your hand is up.
Yes, yeah, I think we did because Dr. Mills was using that to explain
Okay.
a different concept now. So I think we looked at that.
Okay. Thank you very much. Okay, so we are going to go to the next chapter. And a few things have been consolidated over here. So over here, we are going to primarily talk about the Boolean operators. But in addition to that, we are going to look at a few more um, of some other things. So the first thing we want to look at this session is the logical operators. And over here, we use the and, the not, and the or. So this Boolean operation is nothing different from the logic gates we already know from basic electronics. So if we are to look at it from an OR perspective, so we know how the OR gates operate, and then we know how the AND gates also operate. And these operations have their um, computational implementation that we can look at. And I'm going to show you an example of how some of these things come into play. So let's say I give you some instructions, okay? And the instruction is I want let's say Ghana or England to win the World Cup. So this is one statement, but then the operating word I want us to pay attention is the or. So let me use or over here. So I want Ghana or England to win the World Cup. Now, if whatever thing I'm projecting is going to be true, then if Ghana wins, I'll be satisfied. Then if England also wins, I'll be satisfied. So it is a matter of or. Either of them, I'm okay. And then there are instances where we use the AND gates. In this particular instance, we cannot use the AND gates to fulfill this kind of logic. So let me use another example. So with the AND gates, let's say I can say that I want, let's say a laptop and the phone. So the operating word over here is AND. So it is both of these two devices that I'm looking at. So now let's look at how we implement some of these things in computer programming. And we are going to use the concept of logic gates. So let me use a docstring over here. So in logic gates, we know that if it is an OR operation, and let's say we have two inputs. So let's say we have x1 and then x2. And then we expect a corresponding y output over here. So we are kind of trying to draw the true set or the true table. And then for simplicity's sake, let's do 0, 0, 1, 1 over here. And then let me do this. Okay, so this is a, let me close in on this. And then let's do 0. Please, we are getting feedback. Kindly mute yourself. 0, 1, and then 0, 1. Okay, so if this is an OR operation, then we are saying that in Boolean computations, we know that 0 is going to represent false, and then 1 is going to represent true. So let me put that over here. So 0 is equal to false, and then 1 is equal to true. So with this in mind, all that we are trying to say is if input 1 is 0 or false, and input 2 is also false, if it is an OR gate, then the output is going to be a false. If input 1 is false and input 2 is true, then the resulting output is going to be a true because there's an OR gate. Either of them should evaluate to true in order to get an output of true. It is the same thing or same logic applying over here. In this instance, input 1 is true and then input 2 is false. The resulting output from an OR gate is going to be true over here. Then the final combination we have over here is when both inputs are true. The final output is going to be a true statement over here. So this is for an OR gate. Let's look at this for an AND gate. For an AND gate, the combinations in terms of inputs are the same, but then the output changes a little bit over here because in the AND gates, both of them needs to be true before we get a true over here. So in this particular instance where input 1 is true and then input 2 is false, because there's an AND gate, we are going to get a false over here for the Y output. The same logic will apply over here because not all of them is true. So at the end of the day, we get a false over here. All right. Now, it is very much simple, and regardless of the number of inputs that you have, if it is an AND gate, all you need is just at least one of your inputs to be true, then the output is going to be true. And in the case of the AND gates, you definitely would need all your inputs to be true. So if there are 5 inputs, all of them needs to be true before you get a corresponding true from the output end. So this is what we see. Now, in terms of computer programming logic, we use the OR and the AND keywords to execute such logic. Now, in order to also make sense out of this, look, let me just go into incognito mode and then try and open up Facebook for you to see something. Because I want you to see the practicality of everything that we are trying to do over here. So if you try opening Facebook for the first time, okay, with the assumption that you have your email and then your password, what is going to happen over here is you see that the input over here is either expecting an email or a phone number. So whether you put your email here or you put your phone number over here. But when you are done putting whatever thing you choose over here, you need to AND it. So there's going to be an AND operation with a password. But in the case of email or mobile number, it is an OR operation. So you are going to try and simulate something like this with our computer programming that we are trying to do over here. So having said that, let's look at how we do that. So let's look at a typical example. So let's say we have, let's say some things in the database and then we want to do check whether they are the same. So let's call this DB underscore phone, like the phone number inside of the database. Okay, so DB underscore phone underscore number. And let's assume the number is 1122. Okay. The reason why I'm putting up 1122 over here is that most of our phones start with 0244 or 02 whatever. But then typically the system will not accept an integer starting from 0. Okay. So an integer can be 0, but not, 0 to something. So it's either we put this as a string or maybe as some integer number. And that's why I'm using 1122 for our phone number. And let's say our email, db underscore email is going to be equal to, and let's say I have, let's say ml at gmail.com. And then let's do db underscore password. And this password, let's call it ml underscore lock. So this is our phone, this is our email, and then this is our password. So let me also do this. So let me just put all of them as strings. So let me do 0244111, something like this. So this is probably things we have saved in the database, okay? And now we would want to provide the user with an interface to be entering the phone number and stuff like that. So let's call this first underscore input. And that first input is going to be what we have over here, whether the email or the phone number. And then the second input is going to be the password. So first input, we are going to use the inputs function over here. And then we can say enter email or phone number. So the user will see this prompt. Whatever thing the user enters will be sent into the first input variable we have created over here. Now let's also create another one we are calling second input. And then second input is going to accept the password. So I'm going to say enter password. Now this is where the logic comes in, and this is where we apply the OR operations. So first of all, let's break it down and then look at it from just a simple OR operation, okay? Just a simple OR operation. And that OR operation is what we are going to look at for the email and then the phone number or the mobile number. And then later on, we are going to do a combination of that OR operation with an AND operation over here. So we can see that if the first input, okay, is double equal to, and this double equal to, remember the last time we met, we said this is the comparator operator. So if this first input, whatever the user entered over here, is equal to the DB phone number, and then I put an OR over here, or the first input is double equal to the DB email. So the keyword over here is the OR. We are trying to say that if whatever the person enters is the same as the phone number saved inside of the database, okay? Or the first input is actually equal to the email, then something should happen. So let's say I'll bring a column over here and I can simply put out a print statement and say that maybe access granted. So if that's not the case, then I'll do else and then put up a print statement and say invalid credentials, something like this. Okay, but in order for this to also work properly, okay, this is where some of the concepts we know in algebra also comes in. I would prefer, okay, that you put this in some closing parentheses so that this expression, the comparison will be done exclusively, and then this one will also be done exclusively. And at the end of the day, the two expressions inside of the bracket will now be odd. So it is a matter of whether either of them is correct. So now let's test this and see what we get. Remember, the phone number is 0244111, and then the email is ml@gmail.com. So now let's run this. If I run this, and then it is asking me to enter email or phone number. And let me do First of all, let me try using the correct email address, sorry, the phone number. So I'll do 0244 111. So there's the correct one. And then it is asking me to enter the password. I need to comment that one out. But then let me just do 111 over here. Now I see access granted over here. Let me comment this one out so that we are exclusively looking at the email or phone number first. So let me clear my terminal and then run this again. So enter email or phone number. So let's start with the phone number. We'll do 0244 111. So this is going to be accepted into the first number or first input variable. And the first input variable will be used to check, is the first input equal to the phone number? Indeed, the first input is going to be equal to the DB phone number. So in this case, because this is a true statement, we are going to have access granted over here. Now, let me also run this and then try and put in the email address, which is ml@gmail.com. So I'll do ml@gmail.com. And then when I run this, I also see access granted over here. So it is checking either this is correct or this one is correct. However, if for some reason I try maybe putting in the email, but this one I do machine learning at gmail.com. This is definitely going to result in a false statement. And that's going to be the invalid credentials. That's what we are getting if none of these two is correct. So if the email is wrong and we don't also put in the right phone, we are definitely going to get the invalid credentials over here. So let me run this and then use another number. So let's say 0277 555. This is also an invalid or a wrong phone number if you have to compare this with the one inside of the database. So when I run this, we also get invalid credentials. So now we've seen how the OR is working. Let's try and AND this with the phone number. Sorry, with the password. So in order to also get this right, because these expressions are going to be computed exclusively, let me also put this in a bigger bracket so that within this smaller brackets, their individual expressions are computed and then it is all over here. And finally ended with the expression I have over here. So in this new expression, I'm going to say the DB password is equal to, this time around, that's going to be the second, which name did I use over here? Okay, so let me uncomment this one. So that's going to be the second input. Okay. So we are seeing the OR operation happening over here for the email or phone number. And then at the end of the day, everything is going to be ended with a password. It is only going to be true if all these conditions are met. Okay, so now let's run this and see how this one will work in real life. So let's start off with the first one. So email or phone number. Let's use the right email or ml@gmail.com. And then let's use the correct password. The password is ml_lock. So we see that we are being granted access because in the first instance, we are either going to use the email or the phone. So we use the email over here. Now let's try using the phone. So with the phone, I'm going to say 0244 111. This is the correct phone number. And then the password, it is a matter of and. I don't have any laxity over here or option over here with the password. So this one has to be ml_lock. And then we see that access is granted over here. So we've seen an instance where we've used the email and the correct password, and then we have been granted access. And we've seen an instance where we are using the correct phone number and then the correct password over here. We have been granted access. That is how these logic operations are happening over here. Okay. And we are going to see a few more of them when we get to the the machine learning implementation. As a matter of fact, we are going to write some code to kind of do some prediction of these things that we see over here. So at the end of the day, we are going to write our code to take the inputs, do its own learning, and then do some predictions thereof. And you are going to see how these things work out. So that's basically the or and the and. Now the not, as you know, is the inverter, or it will negate whatever expressions that we have. So let's look at a typical example with a not gate. So let me comment these ones out. Comment this one as well. And this too. So with a not gate, let's say I have a variable called password, and password is 1234. And then let's have a variable called user input, and then let's use the input and then say enter your password. Now, typically, you see me do something like if, for instance, maybe user input is double equal to the password that we have over here, then we can say something like valid password, something like this. Else, then let's do a print and then say invalid. So this is definitely one way of doing it, where we are using the how do you call it? Um, the double equal to, okay. So when I run this and then I do 1 2 3 4, this is a valid password. So I see valid password over here. However, if I'm to run this and do 1111, this is definitely not equal to whatever that's saved over here that is being compared. So definitely when I run this, we get the expression invalid. That's what we are executing under the else block. Now, with this said, remember we did this one over here where this is the not equal to. Okay, so this one will negate that. Now, the not is almost like the not equal to that we know, okay, or that we have come to see with this particular one. But then this is a little bit different, okay, except that this is only applicable when we are dealing exclusively with the Boolean operators. So we should bear in mind in that. Now we also have what we call the membership operators. And over here we use the expression in, not in, and then, yeah, in and not in. So in and not in. So let me just comment these ones out and then show you something. So let's say we have a variable called course, and then course is machine learning. So if I ask the question, is machine in course? That's basically the membership operator in over here. I'm asking the questions. Is the expression or is the substring machine inside of the bigger container course? So with this, if I'm to do a printing out over here, the question I'm asking is machine inside of course? It is asking for its membership as far as the variable course is concerned. When I run this, we see that, yes, it is true. Machine is inside of course. What about artificial? The word artificial as we have it, it is not inside of course. So when I run this, it is going to say false. But then if I'm to say artificial not in course, this is going to be a true statement because artificial is not in cost. So when you run this, this is going to give you a true statement as you see over here. So this is almost like English, okay? But then we call these ones the membership operators to check if something is found inside of something, okay? So this is just one of it, okay? Later on, when we get to learn about lists and stuff like that, okay? If let's say I change this into courses and then I put this in some square bracket. We are going to go into details of whatever thing you see over here. And then I put something like artificial intelligence, and then let me put another one, maybe algebra. Okay, so I've basically put 3 courses. The first one is machine learning, the second one is artificial intelligence, and then the third one is algebra, all separated by a comma. This is what we will call a list, and that's what we are going to cover in the next chapter. So don't worry, we are going to go details into that. So over here, I've also changed the variable name into courses. So the question I'm asking is, artificial intelligence is not in courses. Okay. So let me put out the intelligence over here. So the question I'm asking is, artificial intelligence is not in courses. And this is going to be a false statement because I'm trying to say artificial intelligence is not in courses. And that's not the case because it is actually in courses. That's what we see over here. So if I'm to say artificial intelligence in courses, when I run this, we see a true statement over here. Now, the interesting thing is, even if I do artificial in courses, okay, artificial in courses, we see a false statement over here. Because even though we have artificial over here, it is part of a whole thing. This whole thing will be considered as one unit. So as far as it being considered as a single unit is concerned, it is not found in there. And that's what we see over here. So that's with the membership operators. Now, the last one we see over here is the identity operators. And over here, we use a keyword is and then is not. And this is an interesting one. And I have a very good example that I use in class all the time. So look at this. If x is going to be equal to 10, and then y is going to be equal to 10.0. Now let's brainstorm and analyze these things very well. X and y, in terms of value, are they the same? The question I'm trying to ask is 10 and 10.0 in terms of value or magnitude, are they the same? I want to see some answers over here. 10 and 10.0 in terms of magnitude, are they the same? Anybody can?
Yes, please.
Okay, so in terms of magnitude, they are the same. Okay, that's what somebody's saying. Who else holds a contrary view? Oh, that means, okay, yes, I see somebody's on New Love 10 and then 10.0. Are they the same?
Please, I think in terms of data type, they are not.
Okay,
One is integer, one has decimals,
okay,
even though the decimal is just 0.
okay. All right. So New Love is bringing a different perspective, which is a good thing. Okay. I see Christina, your hand is up. Oh, what contribution do you have on this?
Okay. Yes, it's like they're all the same in terms of magnitude. If you can see the data type, like it's completely different. One is an integer, and then the other one is a float.
Okay,
Yes, please. Thank you.
you're welcome. All right, so those are very good observations. Okay. Now, with examples like this, it is very easy for you to figure it out. Okay. We all know our numbers and we all know the various data types. However, if we try and use the how do you call it, the identity operator to actually check the identity of a value or a variable, then we get to see something. Okay, because like you rightly said, if I'm to say x is double equal to y, this is the comparator operator. So this is basically checking for their magnitude. Okay, and in terms of magnitude, it's going to tell me that, look, this is a true statement because 10 and then 10.0 is the same. However, if I use the identity operator and say 10 is 10.0 or x is y in terms of what I've written over here on line 56, but you know that the expression actually implies that 10 is 10.0. over here, when we run this, we see that this is going to be a false statement. So in terms of identity, these are completely different things altogether. Like you rightly said, one is an integer, a whole number, and the other is a floating point value or a decimal fraction. So this is what we have with the identity operator. All right. Now, let's look at the main substance of something that we just touched on briefly, and then we are going to deal with lists. So these are what we call collections, okay, or Python collections. Earlier on, we dealt with the data types. And when you read some books and then other programming tutorials, you see that they usually refer to them as the primitive data types, okay? So it's like they are the ground zero kind of data types that you can work with. But then when you move on to advanced levels, we are going to see that, look, we can put these data types together to form a collection, like a data structure. Now, the first we have over here is what we are going to call a list, or the name of it is actually a list. Now, that's not the only thing we are going to cover. We are going to cover list. We are going to look at tuple. We are going to look at sets, and then we are going to look at dictionary. These are the data structures that are very important that we are eventually going to use when we are dealing with the machine learning stuff. So let's start with the list. Now, usually, I mean, as far as this is concerned, I don't usually go with dictionary definitions of what a list is and stuff like that. But then this is very important so that we know exactly what we are working with. So we are saying that a list is a collection, and the collection is the collection of the various data types that we've spoken about. So whether it is an integer, a float, a boolean, a complex, or whatever, we are saying it's a collection of all these things we've spoken about earlier on. And in the case of list, it is ordered and then mutable. It is ordered and mutable. Now, mutable, I believe, let me just do this so that we are not lost. Okay, so in terms of the word mutable or mutability, it is an adjective that describes something capable of changing. Okay, so order, we are saying that it is ordered. So there's an order in there, and then it is mutable. It can change. All right. Now, a list allows duplicate members. So let's see how we declare a list. So let's say I have a variable called names. And names is going to be equal to the moment I declare something, and for instance, I put it in some double quotation mark. Okay, this becomes a string. If I do something like this, a whole number, this becomes an integer. If I do a dot something, this becomes a float. So Python has its own way of declaring data types and structures. Now, in the case of list, if I want to declare a list, I just have to use the square brackets. The moment I do this, this has become a list. So we can do a printing of the variable names. And then I can also check the data type, just as we used to check the data types of the other ones that we spoke about earlier on. So now when I run this, we get to see that it is as we have declared over here on line 3. And then from line 5, we are trying to check the data type. We see that this is actually a list. So the most important thing is we putting it in a square bracket. Now, what we currently have over here on line 3 is an empty list. So definitely there are no members in there. And the members will come from the collection we spoke about. So let's say I have names. And then let's say I have Amma. I have yeah. So at least I have 2 members over here, or 2 members. And all these members are strange values, okay? Because I've also declared them in some quotation marks. All right. So when I run this, we now see that the list is what we are seeing over here with 8 members listed out over here. Now, this example that I'm giving is a bad example of a list, but the point I want to make is, look, it is not just only strings that we can put together to form a list. What I have next over here is an integer. I'm also putting up a float over here. I can put a Boolean data type true. Okay. The bottom line is it is a collection. And once it is a valid data type, the moment I put it inside of a square bracket, as I've done on line 3, it is going to be considered as a list. So when I run this, we see that everything is showing up over here. And then we are still seeing that this is a list. So the key point is we put whatever data you want to put in there, and then we separate the first one from the second one with a comma. Then after we are done with the next one, we do a comma. And then after we are done with the next one, so we do a comma till we get to the last point. All right. So, like I said, this is a bad example of what a list should be, because we cannot put names and age and maybe GPA and other things all mixed up this way. So this is what we have. Now let's look at a few things. So we are saying it is a collection, okay? And then the next point we are going to say is it is ordered. So the order over here is very important. So let me just use another example that will make sense. So let's say we have courses. And then let's do algebra. Let's do calculus. Let's do something like numerical methods. And then let's do something like programming. Okay, C programming, or maybe programming. So over here, like I said, we separate each member with a comma. So with accounting, we can see that this is the first one, second one, third one, okay? And then we have the fourth one as programming over here. Now, the order in which this goes, okay, is the fact that we have a concept over here. And I think we spoke about that earlier on when we were dealing with the strings, okay? And if you remember very well, one of the key points we made over here was the fact that this one, very good. Python indexing starts from 0. So basically the counting starts from 0. And you saw with this particular example where we are saying that the first character that's in the string is going to take the index position of 0 because counting starts from 0. That's the same principle we are importing over here. Okay, so over here, the first element will take an index position of 0. And then the second element, remember, each element is separated by each other with a comma. So the second one is going to take the index position of 1. And then the third one, remember, with how this one looks like, numerical method, is almost like two things. No, they are one. I mean, it's just a single thing because everything over here is inside of just one string, double quotation mark, okay? So this is going to be considered as 1 unit. This is going to be 2 over here. And then this last one we have over here is going to be 3. But we also saw the trick or the technique we have with the negative counting or the negative indexing. So this can either be a 3 or a -1. Okay, and then this will be a -2, and then it goes on and on and on. All right, so that's with this. So this shows the order over here. Now, let's take note of this, that the order is by the indices, okay, the index. Now we are seeing that it is mutable, okay? So let me just show you this. If I come in here and say that, look, I want to print everything I have in courses. When I run this, we are getting everything that I have over here, okay? Remember, when we're dealing with the strings, let me just go back. We had an instance where we could just print a particular character. So if I want to print what lies in index position 0, I just have to do the courses and then I put in 0 over there in a square bracket. That's the same principle we are going to apply over here. So over here, if I'm to do a square bracket and pass in 0, all I'm trying to say is, look, I'm interested in printing out courses though. However, I'm interested particularly in what lies in index position 0. And what lies in index position 0 is what I have over here as algebra. So now when I run this, we see that I'm only getting algebra over here. All right. Now we are saying that the collection, the list, the things in there, they are mutable. So that means whatever that lies in any index position is changeable. It can be changed. So what I can do is, if I have an expression like this, basically I've grabbed what lies at index position 0, which is algebra. Now, if I do is equal to something like this time around, let me say Python, okay? All that I'm trying to say is, look, take what lies at index position 0 and then change it into Python or reassign the value Python in there. So now if I'm to do a printing of the variable courses over here, when I run it this way, we don't see algebra anymore, but then we see that the first index position, which was initially algebra or was initially declared to have algebra, has now changed into Python because of the mutation we did on line 5. So that supports the argument that the collection, the members over there are also mutable. All right. Now, this is also going to help us do a lot of things, okay? Because if we come back, just like what we already know, okay? If we are to bring in this over here and say 3, remember the starting has been left blank. That means I want to start from printing from algebra. And then 3 is going to be exclusive because that's going to be the end. Remember, that's what I was emphasizing on. We are going to transfer that knowledge over here. So it is the same thing, except that there's a list. So over here, we are expecting to see algebra, calculus, and then numerical methods. So when I run this, that's exactly what we see over here. All right. If for some reason I do, okay, I want to start from 1. Remember, the starting index position is inclusive. So it will start with calculus and then go all the way to the last thing that we have over there. So when I run this, we are seeing this starting from calculus and then everything showing up over here. So we are going to import those knowledge over here. Now, you also will recall that we had some methods with strings. And like I did indicate, those methods were functions that were only applicable to strings. And the typical example I cited that day was the fact that back in primary, okay, you do something like capital A, small a, capital B, small b, capital C, small c, okay. Those who went to Saito were doing A naneba, B naneba, and those things. Yes, A naneba, B naneba is applicable to the alphabet, but nobody went to school to do 1 naneba, 2 naneba, or capital 1, small 1, because that particular functionality is not applicable over here. So we saw that with strings, we can do upper, lower, and all those things. In that same way, list also has its own unique methods that we want to learn, okay? So let's look at a few of those methods over here. So let me just copy this and then put this over here so that we'll start. Now, the first one we have over here is the append method. And the append method will add an element at the end of the list, okay? So when we see the end of the list, it's just going to append. I mean, these are things we hear grammatically, okay? Append your signature. So that means the attendance sheet gets to you and then you write your name and then you sign. Oh, very good. So that's the same thing we are doing over here. So if I'm to do courses, dot, remember, anytime we wanted to do anything or use any of the string methods, we'll first of all bring the string, then we'll do a dot. The dot operator is almost as if I want to go into it. And once I go into, you see that I have quite a number of methods over here. So I'll do dot append. Now the big question is, what do you want to append? Okay, so I want to append maybe statistics. Okay. So over here with what we have done, the statistics course is now going to be added to the last element over here. So now if I'm to do a printing of courses over here this way, when I run this, we see that algebra came in, calculus, numerical method program, and then in the statistics also had to join at the very last end over here. So that's with the append. All right. Now let's look at the other methods we have over here. The next one we have is the clear. So the clear will basically remove all the elements from the list, okay? So this is almost like some of the things you do when you are doing your course registration, okay? So look at the bigger picture. From your side, what you see is you are basically clicking on some radio buttons or some check boxes to add the courses, okay? So look at it from this angle. The moment you click on a course, behind the scene, it is an append function or method that's going to be triggered. And whatever course code or course name will be added onto the list, okay? Then you click on another one, it will be added. Now, assuming you are done with everything and you realize that, look, there is a new directive that the course schools have changed and other things. So the registration needs to be done all over again, okay? I'm not saying that's what is happening, but then we can have an instance like that. So you want to clear everything. Maybe you did a mistake. So all that you can do, if you are to do courses.clear, and I also want you to use your own intuition in trying to understand some of these things. Remember, when we're doing .append, the logical or the common sense is if I want to append something, you want to append your signature, you add your signature. Okay. Now, if you want to clear something, you don't clear something and then put something in there. That's a common sense thing I want you to look at it from. So when I do courses.clear and I try printing out courses, we are going to see that when you run this, this is going to result in an empty list. Okay. Now everything has been cleared. It is empty. All right. Now let's look at the second example or the next one we have over here, which is the copy method. So the copy method will return a copy of the list. This will return a copy of the list. Now, let's say you are doing some shopping, okay? You are doing some shopping and then, like we normally see with Temu and other platforms. So let's say we have the cart and then we bought some shoes. Okay, then we also bought maybe some painting. And then I bought maybe, I don't know, maybe a phone. Okay. So these are the things that I bought. Then maybe after telling a friend, the friend is like, oh, I also want to buy the same things. I don't have the time to go through the items one by one. A lot of these e-commerce websites will probably can generate a code of your last shopping, whatever carts that you can share with a friend, okay? So that's basically going to be that logic over there. That's going to be that logic over there where you can copy the cart. So over here, let's say this is the first cart. Let's call this first cart. And now, if I'm to do first cart dot copy, basically I've copied everything over here. And I would want to save it in a variable called second cart. So now the second cart is going to have everything inside of first cart. So if I'm to do a printing of the second cart, it is definitely a copy of the first cart. So when you run this, we see that it is containing everything, the shoe, the painting, and then the phone, okay? Now, if for some reason, after getting that cart, okay, the person sends me the code, I see the shopping cart. Now, I can also do perhaps maybe an appendment, okay? So maybe I want to add more items over there because maybe in addition to this, I want to buy maybe some lotion or maybe some soup, okay? And then maybe I want to buy maybe some cream. So this is what I've also added onto the second cart. Remember, the second cart is a copy of the first cart. So now if I come in here and then, sorry, I need to do it one after the other. I cannot be appending in this manner, okay? So if I want to append another time, I just have to come and do this over here. So if I'm to do a printing of the second cart, now it's going to be, first of all, the first copy, or sorry, the first cart, which is a copy, and then soap will be added and then cream will be added as well. So when I run this, we see that these are items from the copy, okay, and then the soap came in, and then the cream also came in. So that's with some of the real life examples of these methods as we have them over here. Now let's look at the next one, which is the count. Okay, so earlier on, I forgot to say this. Remember, we are saying that a list will also allow duplicate members, okay? Because some of the collections we are going to learn, we are going to see that they are not going to allow duplicate members. So this perhaps a very unique attribute of list. So let's say I have shoes over here, and then if I'm to do another shoes this way, this is possible. Other data structures that we are going to learn are not going to allow this. So if I'm to do a printing of the first cards as I have over here, it has the duplicate of shoes. So when I run this, we are seeing two shoes over here. And that's exactly what we have done. So the duplicates are going to work. Now with duplicates involved, we can now do a counting of elements. So over here, when I use the count method, the question is, what do you want to count? Maybe I want to count shoes. So it is going to go through the list and tell you that, look, when you apply the count method on first cards, we are going to have two. So over here, if I'm to do first cards.count, and like I said, the question is, what do you want to count? I want to count shoes over here. So I need to wrap this whole thing in a print function because I'm counting on this. So when you run this, you are definitely seeing that I have two shoes over here. All right. Now, if for some reason I am counting what I have over here, which is a shoes with a capital S. Remember what we know, that Python is case sensitive. So what I have over here, even though both of them are shoes, or they all spell shoes, but they are different. So when I run it this way, we are going to see 0 show up over here. All right. So that's just by way of information. Now let's see the other one. The other one over here is index. So the index will return the first element with a specified value. Remember, we know what these index are, okay? So we know that based on what we know, the first shoe over here is index position 0. The second one, which is painting, is index position 1. Then the phone is index position 2. And then the second shoes is index position 3. Now, if I apply the index method, and if I'm to ask the question, the first cat dot index, and then I pass in shoes over here, it is going to return the index where it found shoe first. Okay, emphasis on first. So because the first shoe is at index position 0, we are going to see 0 over here. So now let's do a printing of this and see what we are going to find. So when I run this, we are seeing 0 over here. Now, if for some reason, assuming there wasn't any first shoe, so now the order has changed a little bit, okay? So painting is going to be index position 0, phone is going to be index position 1, and then shoes, now that we are searching for, is going to be index position 2. So indeed, when I want to find the index, we are seeing that I'm seeing shoes over here. All right. Now, what about if I'm looking for AMA? Clearly, there's no AMA over here, okay? When I run this, we get to see that there's a value error. And this one tells us that, look, AMA is not in list. So I always do this in class to tell students, look, whenever you see an error, don't panic. It is telling you what to do, okay? And based on this, if you are writing a big program and then you encounter some of these things, you know that, look, there wasn't any AMA in there, okay? But then we are going to see another, okay, I don't have that over here, but let me just show you quickly. So let's say I want to do shoes, okay? If I'm to do the first cat dot index, you see that the index of shoe is 2. Now, if I'm to do first cat dot find, there's a find method over here. When I run this, list has no attribute find. Where is find? Where? Okay. I think that will be inside of Let me see, tuples, not insert either. Okay, let me come back. Dot, okay, so index, okay, so these are the only methods we see over insert, pop, remove, reverse, sort. Oh, okay. All right. Don't worry, the find will come later on with other things that we are going to look at. All right. Now, the next thing we see over here is sort. And let me be very quick with this one. When it comes to the sort and the reverse and all those things, okay? So if we have something like this, if we are sorting, by default, the sorting is going to be done in alphabetical order. So it's going to be from A to Z, okay? That's with the defaults. So this is the defaults. Now we can reverse it and change things and do it descending order, okay? And now we can look at it from Z to A. So either way is possible. But like I said, the default is A to Z. That's the ascending order. Now, I don't know, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S. So P comes before S, okay? And then we also know that this is almost sorted, okay? So now let's try and use another example. We are playing World Cup, so let's call these countries. And then let's put Ghana over here. Let's put USA. Let's put Japan. Let's put Argentina and the likes. Okay. All right. So based on sorting, at least we know that if you have to sort in alphabetical order, then A is going to come first, Argentina is going to come first, then I believe Ghana will follow, and then yeah. So if I'm to do the sorting over here, if I'm to do countries dot sort, okay, and then if I'm to print it out over here, we are definitely going to see that we are seeing none over here, okay? And then I'll explain that when we get to object-oriented programming. So let me do a printing of the countries. So when I run this, we are see that originally it was presented this way, but then because we are sorting it on line 31, Argentina comes in first because alphabetically, A comes before G, and then G also comes before J, and then USA, which starts with U, is the last one. Now, if I am sorting, and inside of the sort, I do a reverse is equal to true, then I'm reversing from ascending order to now descending order. So this one is going to be from Z to A. So when I run this, we are seeing that USA is starting, and then Japan, Ghana, and then Argentina in that reverse descending order. All right. So that's with the sort. Like I said, this should not be confused with reverse, okay? Reverse will basically take the original list and then change the order for you. So if you are reversing this, what basically this will imply is that Argentina will come first, followed by Japan, followed by US, and then Ghana will also come in. So that's the reverse. It's not necessarily a sorting, okay? Because if you have to sort, it is Argentina coming, then Ghana will follow before Japan and USA. All right. So if I'm to do countries dot reverse, and then I'm to do a printing of countries that have reversed on line 31. When I run this, we get to see that, look, we are reversing the order. So the first basically becomes the last, okay? So the last is Argentina. It is number one over here. Last but one was Japan. It is number two over here. And then it follows in that reverse order. So that's basically the key difference between the reverse and then sort. All right. Now, the remove, we definitely know what will happen when we use the remove method. So remove is going to remove the first item with a specified value, okay? So emphasis on first item. Remember, for list, we can have duplicates. So if I'm to have this over here, and let's say I have another Ghana somewhere here. So there are two Ghanas, okay? If I'm to do countries dot remove, and I pass in Ghana, well, the first Ghana is going to be removed, which is at index position 0. Okay, and then this one is going to be left out. So if I'm to do a printing of the countries list, we get to see that now USA is index position 0 over here. And then it follows through with the others, as we can see, showing up over here. Okay, so that's with the remove. There is another one we call the pop method, okay? So with the pop method, it removes the element at a specified position. All right. So if I'm to do countries dot pop, over here, you are supposed to pass the index, okay? So by default, if you don't pass an index position over here, it's going to pop up the last element over here. So when I do countries dot pop this way, and come back and do a printing of countries, it is going to pop up by default Argentina, because Argentina is the last thing. So that's what we see over here. So Argentina has been taken away. However, if I put up an index position of, let's say, 1, from the original list, the index position 1, it is USA that lies in there, okay? So now it is going to pop up USA. So when I run this, you see that we don't have any USA, but then we have Argentina because we haven't left it blank, okay? We have actually passed an index position in there. All right. So that's with the pop. Now look, it goes on and on and on, because if I'm to do countries and then look through this, we've actually seen how the append works. We've seen declare, we've seen copy, we've seen count, and then you see that there's another one called extend, okay? There's one called index. There's insert, and then pop, and then remove, reverse sorts. So we've covered more than 90%. I think the only one we haven't looked at is the extend, and then I think insert. But you know what insert will do? Typically, append is going to append at the last signature. Sorry, at the last index. Okay, but then with the insert, we need to specify the index position where we want to insert. So over here, remember Ghana is at index position 0. Okay, the first Ghana. Now, if I'm to do countries dot insert, and then passing the index. So let's say index position 0, and then the object I want to pass there is, let's say, Brazil. Brazil is now going to be inserted, okay? And over here, I've passed an index position of 0. So when I run this, now we have, okay, I'm printing this one. So let me copy this. Sorry, comment this one out. So when I run this, we get to see that, look, Brazil has now been inserted. So that's the key difference between the insert and then the append. Append is going to take whatever thing you want to add into the list to the last element. But then with the insert, we specify the index position. So for instance, if I put in 3 over here, let's count. This is 0, 1, 2, 3. So we are going to have Brazil before Ghana and Argentina if you have to run it this way. So when I run this, you see that we have 0, 1, 2. We are seeing this show up over here. All right. So that's with the list and then its methods. For these ones, we can move very quickly because we have an idea of how things work out over here. So a tuple is a collection which is ordered, just like list, okay? However, with tuples, it is not mutable. So list was mutable, tuples are not. And tuple also allow duplicate members. So let's look at something interesting over here. Remember, same thing, names or countries or whatever, okay? If I'm to do countries and then do this, just by using the square bracket, there's a list. And we saw this by printing out countries and also printing out the data type of countries. And we confirmed that this was indeed a list, okay? In the case of tuple, the declaration is very simple. All that we bring is we use the parentheses or this curve bracket, okay? So the moment we do this, Python will understand that, look, we want to deal with tuples over here. So when I run this, we see that, look, this is also a tuple, as we are seeing over here. All right. Now, the next thing we need to look at is the members. And over here, we are seeing that the members are ordered. So look at this. The example we used earlier on, look, I can put in Ghana over here, and then USA, and then Japan, and then China. No, China is not playing. So let's do Tunisia. Okay. So this is a new tuple that we have with these members. Okay. Now, if I'm to do this over here, that means I'm only interested in what lies at index position 0. And because this is ordered, when I run this, we see that it is Ghana that I see over here. Okay. When I do index position -1, based on what we know, we are going to see that it is Tunisia that's going to be printed out. So this is pretty much what we know. Remember with lists, I did something like this. Okay, index position 0, which was Ghana. And then remember with the list, they were mutable. Things could change in there. But in the case of a tuple, if I'm to do this and then bring in Brazil over here, and then do a printing of countries, when I run this, we run into problem. So it tells us that tuple object does not support item assignment. The long and short of it all is it does not allow mutation, okay? It is not mutable. You cannot change things in there once they've been declared. So that's one of the key differences between a list and a tuple. Now, we're also making the point that it allows duplicate members, okay? So even though we cannot do this as we have done on line 5, we can bring in maybe a couple of Ghanas over here. So maybe Ghana, there's a duplicate of Ghana, and then let me also do a duplicate of USA. So when you run this, we see that indeed Ghana is duplicated. The order is very important, but then we cannot mutate. We cannot change items in there. All right. So that's one of the key differences between the list and the tuple. Now, as far as tuples are concerned, okay, remember with a list, okay, whatever object that you have, when you do a dot, that means you want to go into it. You can see the methods over there. Over here, we only have just 2 methods. So we don't have a lot to do over here. However, we are going to use tuples a lot. Okay, we are going to use tuples a lot. So over here, we can do a count. And obviously, we can count maybe the number of Ghanas over here or the number of USs. So if I'm to say countries or counts, and I put in US over here, clearly we can do the counting simple over here. We know that there are 2 USs, okay? So when I run this, we see that we see 2 over here. It is just the same concept we have with the list. And then if I'm to do index, this is going to return the first index position where USA was first found. So over here, 0, 1, 2. So index position 2 is what we expect over here. If for some reason there was this USA wasn't there, okay, then it's going to be this one. So this is going to be 0, 1, 2, 3, 4. So when I run this, we are getting 4 showing up over here. That's basically the 2 methods that we have over here. But there's something I want us to pay attention to because eventually when we start dealing with the ML proper, we are going to see some of these things. And this is the concept of unpacking, okay? Unpacking. So let me give you a typical example. Typically, when we are working with ML systems, when we are building these models, we'll split our data sets, okay? We'll have a part we are going to use for training, and then we are going to have a part we are going to use for the testing. So let's say we have a data set, and these are just some arbitrary values. Typically, we'll use, let's say, 80% for the training and then 20% for the testing. So over here, I have 80 and then 20 showing up over here. I've declared them inside of a tuple because I've used the curve bracket. So let me call this data. So data is going to be equal to 80, 20, okay? And if I'm to do a printing of the variable data and then also check the data type of data, as I have it over here. Just for confirmation, we see that, yes, indeed, there's a tuple, and then this is what we have. Now, because we want to do something called unpacking, okay, and we know that, okay, what lies first is our training part, and then what lies second is our testing part. We can do the unpacking right over here. So over here, I can see training sets or training parts, comma, testing sets or testing parts. With what I've done over here, what this basically will imply is that, look, the first variable will be assigned the first value I have over here, and the second variable will be assigned the second value I have over here. So this time around, it is the same data, but then I've decoupled it, okay? I don't want to merge everything. I've segregated. I've done the splitting into the training sets and then the testing sets. So if I'm to check out the training sets, when I run this, we are going to see that that's going to be the 80 because this value has been assigned straight away. This is what we call unpacking, okay? And then let's look at the testing sets. We are going to see that the testing set is going to be 20 over here. That's really this value. Let's assume we have this. Now there's no proportion over here in the sense that we have two variables and then we have three values we are trying to unpack. So the common sense thing is, okay, the first one will go here, the second one will go here. What about this one? Okay, I think earlier on when we started this, we spoke about this when we were looking at the assignment operators, okay? And I think I made the point that we can create our own law over here, which we call this the law of conservation of data. I don't know if you remember, okay? That look, data is neither created nor destroyed in this particular computer programming exercise that we are dealing with. So we cannot create this data and not put anywhere. So definitely when I try running this, it tells that, look, too many values to unpack. So it expected two. Okay, the values were too many. So the moment you see things like this, you know that, oh, okay, maybe you are trying, because look, what is going to happen is most of the things, and I'll come back to this when we start building the models, most of the things that we are going to work with are going to be like what we call the black box model, okay? For those who don't know, let me just show you this. The black box model, what that basically means. So, very good. When you look at this particular diagram, okay, most of the things that we are going to do, we are going to put some inputs into a black box, okay, and then we expect some output at the end of the day. Now, what I've seen with a lot of students is because most of them don't know exactly what goes on within the black box, it is very difficult trying to figure out if you crash or when you hit a stumbling block, okay, because we don't really know. So that's what we are trying to figure out. And you are going to see that with the black, so we are saying that a black box model is a system or algorithm or process where input outputs are visible, but the internal decision-making process logic are hidden or incomprehensible to human. So most of the things are going to be hidden or incomprehensible. However, if we understand the fundamental concepts and we get something wrong, like what we are trying to do over here, we get to see that, look, too many values to unpack, expected two. Okay, so in the black box, it is expecting two. So I only have to present two over here, or maybe three, or something like that. All right. So that's with unpacking. And we are going to see more of it later on when we work with proper data sets. All right. So that's going to end the chapter on tuples. Let's quickly move on to sets over here. So with set, we are saying that set is a collection which is unordered. Okay, so this one is also introducing something new over here. And it is not mutable over here too. So now let's look at this. So let's have the countries, okay, once again. And with set, remember when we do a square bracket, this is going to be a list, okay? When we do this, this is going to be a tuple. In the case of sets, we do this, which is the curly braces, okay? But then this is not the only thing we do. So let me just do this. If I'm to do a printing of countries, as I've declared it here now, and then if I'm to check the data type of countries this way, I'm seeing that when we do this, the country collection becomes a set. However, when we try running this, we see that, look, this is not a set, but then it is a dict. This is a dictionary, okay? And that's what we are going to talk about next over here. So, I don't know the logic behind this, but as far as Python programming is concerned, the way we declare sets and dictionaries are the same, okay? With a comma, I'm not done. There's a slight difference in there. So over here, if I want an empty list, look, I can just do it this way and then I get an empty list like this. If I want an empty tuple, I do it this way and I get an empty tuple this way. However, if I want an empty, how do you call it, dictionary, I can also do it this way and then indeed I get an empty dictionary. However, if I want an empty set, I cannot do it the usual ways. I just have to use this, okay? So I just have to type in set and then bring in this parenthesis this way. So when I run this, we now get to see that, okay, now there's a set and then it is of a data type set over here as we are checking from line 6. All right. However, let's get back to this. If I do it this way, we know that this is a dictionary, okay? However, the moment I pass in some members, for instance, I put in 1 over here, then this becomes a set. So yes, it is the same curly braces, but then the moment you start putting in numbers or any other thing, then it becomes a set. So now let's put the countries over here. And let me just show you something. So let me put Ghana, comma, and then USA, comma, Japan. Then let me do Mexico here. So I have 4 countries, okay? Ghana, US, Japan, and Mexico. Now we are seeing that for the set, it is unordered. Remember, with the list and the tuple, their order was by the indices, okay? So index, whatever element that lies on index position 1 and then 2 and 3 was the order. In this particular instance, we are seeing they are unordered. So what I'm going to do is, let me comment this one and kindly pay attention. I'm going to run this about maybe 5 times, okay? And each time we are going to make an observation. So when I ran it the first time, look at the order in which things are appearing over here. USA, Japan, Mexico, Ghana. When I ran it the second time, Ghana, US, Mexico, Japan. When I ran it the third time, we are seeing Ghana, Mexico, Japan, US. Fourth time, US, Mexico, Ghana. So you could see that almost every time when I run it, the order changes over here, okay? In the case of the list and the tuples, we're the same, okay? No matter how many times. But in the case of the sets, anytime I run it, it changes. Let's just pay attention to the first element we see over here. Now we are seeing Ghana. When I run it again, we are seeing Mexico. When I run it again, we are seeing Ghana. Now Japan, Japan again, USA. So almost every time, not just the first element, but then the other element also changes as well, okay? And that's why we are saying that, look, it is unordered. There's no order over here. So we cannot confidently say that Ghana is lying at index position 0. Because anytime, almost every time we run it, something changes. So index position 0 is not exclusively for Ghana as far as sets are concerned. Okay. Now, remember, we could also do a confirmation of the order and then put in maybe this over here. And the question typically will be asking, look, I'm interested in printing our countries, but I'm interested particularly in what lies at index position 0. Because countries over here is declared as a set. Now, when I run this, I get a problem. And the problem is telling me that, look, set object is not subscribable. In other words, look, there's no order over here. So you cannot select from a particular index position in here. So that's with the sets. Now we are seeing that it is not mutable. Look, first of all, we cannot even select the particular thing to even do is equal to something, like we saw with, how do you call it? The list. So that's very clear over here. We cannot do this. But then let's try this and see. So let's see. We just want to, and these are some of the things I want you to try, okay? Look, even if something is not possible, try and figure it out yourself. Write the code to test if by any stretch of miracle, something different is going to happen. So let's say I do this and then I pass in Brazil over here, like I did with the list and the tuple. And then let's uncomment this one and then try and see if Ghana, which I know is not even the index position of 0 over here, but then let's see if this will work. When I run it, we get to see that, look, the set does not support item assignment. That's the same thing we saw with the tuple, okay? So we cannot mutate or change things over there. All right. Now, the big question is, it does not allow duplicate members as well. So look, if I have this, and then I have another Ghana, and then another Mexico, and if I try printing out countries, and then I run this, look, it only gives me exclusively one element each of whatever thing that may happen in there. So as much as I have two Ghanas, okay, the first one and then the last but one, and then Mexico, I have two Mexicos over here. It only gives me one Ghana and then one Mexico because it does not allow duplicate members. So that's also very key over here. Now somebody may ask, look, this one is getting a little bit funny over here because it's almost as if you cannot use this for anything. Look, we can actually use this for something. So let's assume you are working with some data, okay? And now I've changed this into a list. Remember, lists will allow duplicates. So maybe you have about hundreds of thousands of names or some data points, okay? And you are told that, look, get rid of all duplicates. Now, sets are going to help you get rid of all duplicates because this is what we are going to do. If I'm to print out countries over here, I get everything with all the duplicates. So I see Ghana and then the other Ghana over here. I see Mexico and then the other Mexico over here. We can use the concept of type casting. I hope you remember that because when we're dealing with, I don't know whether we can find that here. Good. Not here per se, but then I think concatenation, was it concatenation or whatever? All right, let me just go back to that point. So with typecasting, I remember very well that we could do something like this. If let's say age, okay, and this is a string because it is declared in some quotation mark, I mean double quotation, single quotation mark. If I'm to do capital letter H, it's going to be equal to int, and then I pass in small letter h. All that I'm trying to do is, look, I'm changing the data type of what I have over here on line 7 into an integer, okay? So this time around, if I'm to print capital letter H, and then also print the data type of capital letter H, we are seeing an int showing up over here, okay? And indeed, the data is also going to show up over here with 12. All right, that's the same thing we are going to do because look, whenever you want to typecast into a different data type, the name you see, okay, when you try and check its type is what you use. So over here, I wanted to change into an int, so I use int. If I want to change into a string, I'll use str. If I want to change into a Boolean, I'll use bool. Those are the things we see when we do some of the things we do over here. All right. So that's the same concept you are going to use over here. So yes, we have a list. It has duplicate members. Maybe there are about 1,000 of them. We cannot look through it one by one with our eyes and even remember that, look, this is a duplicate of the other. If it is a list, then we can simply do a typecast of that list into, for instance, a set. And by the inherent behavior of how a set behaves, it is just basically going to drop all the duplicates. So let's create a new variable over here. And then let's call this drop underscore duplicate. And drop duplicate is basically going to now take this list and then put it inside of a set, do a typecasting over it. And the list is countries. So now if I'm to do a printing of drop duplicates, as I have it currently over here, it has now changed everything into a set now. However, the most important thing is it has dropped the duplicates. So that's one of the beautiful things we can do over here. Okay. So instead of going through that thousands of lines of data entries one by one, you can just use a typecasting technique to get rid of the duplicates, and then you are rest assured that based on the inherent behavior of the sets, you can know that, okay, this is going to work. So let me just comment this one out. Now, as far as the methods with sets are concerned, they are also very few. So if I'm to do countries, which is the sets, sorry, let me bring it back. This now making this a list. Let me change this back into a set. And then the duplicates are not needed over here because they are not going to even be recognized. Okay, so when we have this and then we do a dot, we'll go into it. We see that we have the add, okay? So we can be adding things. We have the clear, and the clear is just like what we know from the how do you call it, the list. You also have a copy. You can create a copy. You can also check the difference underscore update discard intersection updates is disjoints and is subsets and all those things. Okay, so basically some of the things we know in the real examples of sets are some of the things we can do over here. So we can do union, we can do intersection and all those things. Okay, so I think at this point, union and intersection is something that we would want to look at. So let's say, let me use this one. So I have this Ghana, whatever. So let me say, these are the countries playing in the US. Okay, so countries playing in the USA. Okay, and then countries who are playing in Canada, something like this. And you know that some of the countries for instance, Ghana, you played that first match in Canada, the next match is going to be in USA. So maybe something like this will happen. So let's say Ghana is playing both in Canada and USA, and then USA will not play in USA, but then over here we can have Canada will be playing in Canada, and then let's say um, Egypt. So let me do Egypt over here. So let's say I have these ones, okay? Clearly you can see that when we take inspiration from the concept of sets that we know, okay? If you are to say that I want to see the intersection between countries underscore USA and countries underscore Canada, the intersection over here is Ghana, okay? All right. And then if you are to look at the union is combining the two elements, the elements of set one and then elements of set two all together to form that union. All right. So now let's just first of all look at the intersection. So if I'm to do countries USA dot intersection, and then I pass in countries Canada this way, okay? And then if I run this and then print this out, we are definitely going to see that, look, we have Ghana over there because Ghana is an intersection, okay? That's a common one we have in there. And now if I'm to do the union is going to combine everything, but because I have Ghana here, and the set will not allow duplicates, it will just pick up just one Ghana, and then it will combine the rest. So when I do countries underscore USA union, countries underscore Canada, when I run this, we see that we have everything joined up over here, but because Ghana is appearing twice, and then the list inherently will not allow duplicate members, we don't have Ghana appearing twice over here. So that's a key difference, or that's one of the unique methods we have in sets that will not appear in list and then in tuples as well. The other ones, like I did indicate, For instance, like the add, the clear, copy, and all those things are more or less things we saw in the list method. So we are going to conclude on that. But then look, once again, at your own time, just try examples of the other ones. Okay. So for instance, one that we haven't made mention is the difference. Okay. So when I do difference, what do I want to expect? Now, usually when you do this and you have your system set up like the way I showed you, okay, when you hover your mouse on the method, it's going to tell you what this method is all about. So this one will return the difference of two sets, okay, as a new set. So all elements that are in set one, but not the other sets, okay? So, okay, if I want to see the difference between set one, this is almost like the intersection, okay? So countries of Canada and then let's do underscore USA. So this is going to give me the difference between these ones or these sets I have over here. So when I run this, I see that so countries of Canada, which is what I have over here, the Ghana, Canada, and then Egypt. Okay. And then okay, so the difference is Egypt and Canada because this one is the common one out, okay? And then if we are to reverse the order and do underscore USA underscore Canada over here, then that's also going to be a different conversation because that's also going to be the USA, Japan, and then Mexico. Okay. So that's what we have over here. So let me go back to the reading over here. Return the difference of two or more sets as a new set, okay? I.e., all elements that are in this set, but not the other. All elements. Oh, okay. So all elements that are in this set and not the other. So for instance, these ones are in this set and not the other one. Okay. So it's kind of makes sense one way or the other. All right. So let's quickly jump onto dictionaries because that's the last thing we are going to cover with this collections. So a Python dictionary is a collection of key value pair of data, okay? It is ordered and mutable, and it does not allow duplicate members. Does not allow duplicate. I think when you go through the GitHub repo and you download this, I think there was a mistake over here, which I probably wrote it allows duplicate members. Kindly do that correction over here. Okay. So we know that when we do this, this becomes a list. Okay. When we do this a tuple. When we do this originally, it is how do you call it? A dictionary. Okay. So if I'm to do a printing of names and then checking the data type of names as I currently have them over here, we are going to see that this is a dictionary. However, the moment I put in some value, for instance, like 1, then this one becomes a set. So how then do I put in values inside of this to make it a dictionary? And the answer lies in the fact that it is a key value pair of data. So this is almost like the dictionary that we know, okay? When you open the dictionary, you have the keys and then you have the values. The keys are basically the vocabulary or the words, okay? And the value is the definitions you see under each word. It's almost like the Bible. We have the chapters, okay? And then under each chapter is going to be a text that's maybe John 11:3. This is what maybe John accounted or maybe Jesus was saying or something like that. All right. So that's what we are going to see with dictionaries. They are going to be key value pairs. So over here, in order to work with dictionaries, we know that yes, we are going to put them in this particular curly braces, but it's going to be a key value pair. So over here, the way we go about this is we have to specify a key. Now, as far as the keys and the values are concerned, the key can be any data type and the value can also be any data type. So let me put that over here. The key can be any data type. And then the value can also be any data type. And by data type, I'm referring to the primitive ones. So for instance, we can do int, we can do string, we can do Boolean, we can do complex, and all those things we know, okay? We can also do the collections. So the key can also be a collection. Let's say it can be a list, it can be a tuple, it can be a set, it can be a dictionary itself, it can be anything. And the values can also be an int, a float, a bool, a complex, and everything that I've set out over here. It can also be a list, a tuple, and any other thing, okay? So that's with it. So now let's look at this. Now let me just open this up this way so that we have a lot of space. So let's say I have 1. So this is 1. Then I'll do colon. And then maybe I'll type in a string. So over here, what I have is, yes, I have a key and then the value. So the key will come before the column, and then the value is what is going to show up after the column. So now when I run this, let me do a printing of names over here. When I run this, we are going to see that, look, this is what we see, okay? And indeed, if I'm to check the data type of names over here, let me open this up a little bit. We are going to see that this is what we have, and then this is indeed a dictionary, okay, a dict. In that same manner, if I do a comma, then that means I want to add a new entry, okay? So the comma can come in, and then let's say I do, let's say true for Boolean. So now the key is going to be true, and then the value is going to be maybe a list, 1, 2, 3, okay? When I run this, it is still accepted. So you could see that, what's happening here, what's happening here. So I have 1, 1, 2, 3. Let me just do this and see. Yes, I was expecting something like this. Okay. Let me see this. Okay, so why was true not showing? Okay. All right. Don't worry. I'll try and find answers to this. I'm seeing this for the first time. But then when I do false over here, this one shows perfectly. Okay. So I see that for the first entry, remember what separates each entry from each other is going to be the comma, just as we saw with list, tuples, and then sets. Okay. So this is going to be the key, and then this is going to be the value. It does not really matter the key value per combination. Okay, so let's say I have a 2.4. So now the key is a Boolean data type. And then the value can also be another Boolean data type. Hey, sorry, a floating data type, okay? The value can also be another floating data type. So we can go on and on and on with this, okay? And we are going to see that these are the keys and these are the values. So that's the main thing over there. But then you will not typically find something like this, okay? Usually, maybe for this one, let's say I have maybe something like training sets. So training data 1. Then maybe the training data is maybe 20, okay? So let me duplicate this a number of times and then do some changes over here. Training data 2, training data 3, training data 4. And then maybe this is 40, 60, and then 80. So this is a typical dictionary where we have key value pairs. So now when I run this, we see that this entire dictionary, okay, and then we are seeing that it is of a data type, dict or dictionary, as we are trying to print out over here. All right. Now, dictionary will also have its own methods, okay? So we can see that, yes, we are seeing copy over here, which is basically going to do a copy. We see clear, it will clear everything up, and then we see remove, and then the keys, and then the value. We are going to come to the keys and values. But then let's go back to our working definition of what a dictionary is. Now, we are saying that it is ordered. Dictionaries are ordered. Now, earlier on, when we're dealing with the other collections, like the lists, we knew that the lists were ordered, and they were ordered by their index positions. Okay. We also saw that tuples were ordered, and they were also ordered by their index positions. In the case of sets, they are unordered. So anytime we run them, you see that there was that randomized output. In the case of dictionaries, yes, they are ordered, but their order is not by any index position. Their order is not by any index position, because if I'm to come in here and do slash, I can put in 0 over here to say that, for instance, this is at index position 0, because the moment I do this, I run into problems. You say now, look, there's a key error, and it tells you that 0, there's nothing in for 0 over here. All right. So if I want to check the order over here is by the keys. And remember what I said, what comes before the column is the key, and what comes after it is the value. So over here, if I come in here and do slash and then bring this one up, all I'm trying to see, just as maybe with a list, I'll do the square bracket and then put in a 0 over there to tell me what lies at index position 0. Over here too, when I do it this way, it is going to tell me what lies at index position training data 1. And that value is going to be 20. So when I run this, I see 20 showing up over here. Over here too, when I do what lies at index position training data 4, that's what I see over here. I'm going to see 80. What about if I do what lies at index position 44? Remember, we saw some things out of range and all those things. This time around, it is definitely also going to give me an error, but then the error is very simple. Like, look, there's a key error. So over here, the key is the indices that we want to refer to, because that will reference its corresponding data that is assigned to it. All right. Now, with that said, if I'm to do the dictionary dots, once again, I want to go into it. If I go into it and do dot keys, this is going to give me the keys. Remember, I'm saying that the keys are what comes before, okay? And then what comes after is the value. It's like when you open your Bible, like I said, the keys or your dictionary, the keys are the words. What comes? Okay, first is the word, and then the value, the description is what follows. That's exactly what we see over here. So when I do names or keys, when I run this, we see that, look, the keys is what we see over here. Training data 1, training data 2, training data 3, and then training data 4. Those are the keys that comes before the values. And in that same way, if I'm to do dot values over here and run this, we get to see that, look, the values are definitely what we see over here for the data. So over here, okay, over here, we can be very smart about this and then maybe do some manipulation. So maybe I can see that, look, the data itself is going to be equal to the variable, which is names. Okay, unfortunately, it's a bad example of a variable over here. So dot maybe, and I can do values over here. And whatever values we get will be sent into the variable called data. So now if I'm to do a preview of data, I'm going to see that there's going to be a dictionary or a dict value. However, maybe if I'm interested in what lies at index position, the first one, this time around, this is a dict value. It is a dictionary, okay? The way this one is inherently. So what I can do is when I do a slash or slicing of index position 0, now I get to see that, oh, sorry. So did values are not subscribable. Let me check the data type of this and see. Okay, it is of a class dict values. Okay, no problem. So this is almost behaving like the way the tuples behave. Okay, and that's sorry, yeah, the way the tuples behave when you try and put in values over there and stuff like that. All right. And then, okay. Data values, mapping, block, other things. All right. Now, let me also mention that, you see, whenever we have some of these things, okay, these data structures and stuff like that, when we do a dot, we see some the methods that are applicable, and then we see some other ones. So for instance, these are the methods. The one we have with a square or like the box, okay, icons, those are the methods. Now we also have these ones where we see they are almost the same, okay, but these ones we have an underscore. These ones we call them magic methods, okay. We call them magic methods. When we deal with object-oriented programming, we are going to see a few of these magic methods, and then we are going to come back and see how meaningful they are when we are writing our code to build our models. All right. I think our time is up. It is 7. And then if there are any questions, I will answer them. I have prepared an assignment. The next time we meet is going to be on Friday, so at least we may have a day or two to actually test your hands on these things. And the assignment is basically going to cover everything we have done, from the list to the tuples and all these things over here. All right, please, any questions?
Yeah, if there are no questions, it means it's okay. So what we will do is we will wrap up this week with the Python programming.
Sure.
And then next week, Monday, we start with data preparation for the model development. So all the things you have said here and then the last week, we are now going to apply them on the data, the pre-processing of the data analysis and analytics and everything. We are going to apply almost every tool that has been introduced here into the data